Hello friends! I've already gone ahead and created a new scene in a new folder for this lesson. Today we'll learn how to control the flow of our scripts to run different lines of code, making choices about whether or not we can see. So let's attach a new script to the root node of our scene and name it Vision. We will start our script by overriding the base node's definition of the ready function. The most basic method of controlling the flow of our scripts is the if statement, which starts with the keyword if. If is followed by a conditional statement which must either be true or false. For now, let's put true, which is then followed by a colon. Similar to the colon at the end of our function declaration, this marks the end of the statement, and continuing to the next line, it is automatically indented another level. Any lines of code following this if statement which are indented will only be run if the condition of the if statement is true. So let's print out something like the condition was true, and then run the current scene to see our print statement working. If we change true to false, we can see that the print statement is skipped over this time. We can add another line after the if statement's indented body on the same indent level as the if statement, simply with the keyword else followed by a colon. This creates another conditional body that will be run only if the condition of the original if statement was not met. Let's duplicate the print statement and change it to say something different. Since the condition was false, the else block was executed instead of the if block. And if we change the condition to true, the reverse will happen. This isn't very useful if we always know the outcome of the conditional statement to be true or false, but we can replace it with a variable. Let's declare a boolean variable which is whether or not the light is on in the room. Booleans are conventionally named in such a way that they imply their use as a condition. In this case, light is on is implied to be true or false based on how it is named. Now our if statement can set its condition to be whether or not the value of our variable is equal to true. When comparing two values to see if they are equal, we use a double equal sign, known as the equal operator, which is different from a single equal sign like we used before as the assignment operator. We will then print out either I can see or I can't see as a result of whether or not the light is on being equal to true. Since the default value of a boolean is false, we can see the output as I can't see. But if we set the variable to true, it changes to I can see. Since the variable itself is a boolean, either true or false, we can remove the comparison operation altogether and just use the boolean as the condition and get the exact same result. We can reverse the value of any boolean, meaning if it is true it becomes false, or if it is false it becomes true, by using the keyword not. Like the str function we used in the previous lesson, this only changes how it is being used in the local context and does not actually change the value stored in the variable. So if not light is on, then we can't see, and else we can see. Not can also be represented by an exclamation point. Let's change the value of light is on and run it again. I'll then revert these changes back to how they were before. We can make our conditions much more complex by combining multiple conditions together using logic operators. Let's create another variable named hasDarkVision. This variable implies that we should be able to see even if the light is not on. So we can add to our if statement's condition to be either that the light is on or that we have dark vision. And if either of these conditions are true, then we can see. Only if both conditions are false will it result in us not being able to see. What about if instead of having dark vision, we are wearing night vision goggles, since they only allow us to see in the dark but not in the light? Changing the variable name, the condition of our if statement needs to change, since if both conditions are true, then we shouldn't be able to see. Only if the values of these two conditions are different should we consider the condition to see to be met. We can use the not equals operator to check if the two values are not equal to each other. If you are familiar with logic operations, this is known in other languages as an exclusive OR. Now, only if either the light is on or we are wearing night vision goggles, and not both, will we be able to see. Next, let's consider that our hypothetical person might not be human, and add a variable for the number of eyes that they have, which should be represented as an integer. For now, we'll give it a value of 2 eyes. Ignoring the other variables, what would be the condition that we set to be able to see based on this variable? If the number of eyes we have is anything greater than 0, then we should be able to see. We can also express this using another operator, greater than or equal to, and change the right-hand side to 1. So they must have eyes greater than or equal to 1. These are comparison operators that will return a boolean result by comparing the value of numbers on its left and right sides. We can logically conclude that it should be impossible for any creature, human or otherwise, to have a negative number of eyes. The value of our variable should only be 0 or something larger than 0. And the condition to be able to see really boils down to these two options. Do we have 0 eyes or non-zero eyes? Just like the Boolean variable can be used implicitly as a condition, an integer can also be used in this way, with 0 being considered a false condition and anything other than 0 being considered true. The same logic is also applied to floating point numbers. We can declare a float variable, let's name it range of vision, and give it an arbitrary value of 7.8 meters. We can use our comparison operators to determine whether this number is greater than, less than, or equal to a certain value, or we can use it implicitly in its own condition, with 0 being considered false and anything else being considered true. What about strings? Let's change things up slightly and declare a string variable for what we heard, and give it a value of bumps in the night. Then we might logically use this as an if statement, as if what I heard was not an empty string, then we can say I heard something. Otherwise, I heard nothing. And just like the other variable types, we can drop the comparison and use the variable itself as the condition. With all variables, their default values are considered to be false, and anything else is always considered to be true when used as a condition. If we declare a variable without a type, let's call it what I am looking at, but don't give it a value, then we already know its default value will be null. Even without a type or a value, any variable can be used as a Boolean condition. Any variable that is empty, meaning its value is null, is considered to be false. If we were to populate this variable with an object, then its value as a condition would be considered true. We don't currently have any other objects to play with, but we can always use ourselves. So let's set the value of what I am looking at to be the keyword self. And this results in being able to see. In the next lesson, we'll use loops to repeat lines of code multiple times. I'll see you in the next lesson.